All right, what we're learning about next in the unit is complex fractions. And the word complex just means complicated. So we're talking about complicated fractions. And what a complex fraction is it's a fraction that has more than one fraction inside of it. And I'll show you what I mean. So for the first fraction, we have 4a squared minus a minus 5 over 20. I'm showing a big line right here. So this is the top of our overall fraction. And then on the bottom, we have a over 5 minus 1/4. So we have an overall fraction that has three fractions inside of it. That's what makes it complicated, because it's one fraction that's got three fractions as parts of it. Now you can see overall that we have addition and subtraction within this one problem. That's part of the complicated fraction, is that it's got addition or subtraction as part of it. It's also got division as part of it. We've got a fraction divided by a fraction. And so that's what always happens with the complex fractions, is that they have some part of it with addition or subtraction, and then overall it's a fraction, so there's division as part of it as well. So our first step with the complex fraction is going to be to take the part where you have addition or subtraction. It could be on the bottom, it could be on the top, and you're going to get a common denominator between those two pieces. And the nice thing about this is that since we have done this part where we got common denominators and put them together, the common denominators for these types of fractions, these complex fractions, are usually a lot simpler than what we've done in the past. So between 5 and 4, the common denominator is going to be 20. So between 5 and 4, that common denominator is 20. So this one, that's 5, so we need to multiply the top of the fraction by 4, the bottom of the fraction by 4. That one's 4, so we're going to multiply the top by 5, the bottom by 5. So pretty easy fix there. Okay, so I got my common denominator. I'm going to go ahead and rewrite what I have. So I have 4a over 20 minus 5 over 20. Is a minus 5 over 20. 4a minus 5 over 20. Okay, so now at this point, it's kind of transitioned into a problem like what I've seen before. It's a fraction divided by a fraction. And we don't typically have it written like that, right? We're used to seeing a fraction, we're used to seeing it written like this. Fraction divided by fraction. That's how I'm used to seeing it written. And divided by a fraction means I need to do keep it, change it, flip it. So I'm going to go ahead and write that over here. Keep, change, flip. Okay. So I've got 4a squared minus a minus 5 over 20. Change it to a multiplication problem. Okay. Now at this point, I just put what I have, and then I need to factor to see if anything can cancel. So the 20s aren't going to factor, obviously. This looks like a factor all on its own. It looks like a factor that I would have gotten from a slide divide problem. There's no GCF between 4 and 5. That's already done. So the factoring that I need to do is from right here. That's a trinomial. It's got a 4 in the front. It's not a trinomial that would have a GCF. It's a trinomial that's actually a slide divide problem. So I'm choosing two numbers that multiply to negative 20, but add to negative 1. And the two numbers that do that are negative 5 and positive 4. And then I'm going to divide them both by 4. And so that slides to the front. Then 4 divided by 4 is 1. Okay. So I have 4a minus 5 a plus 1 over 20 times 20 over 4a minus 5. And so now I can go ahead and cancel all the things that cancel. So I've got the 20s cancel, the 4a's minus 5 cancel, and so my final answer is a plus 1. I'm finished. Okay, so let's walk through that process again. We'll do another problem. So here, I've got 1 over u minus 5 over 9 divided by 5u minus 9 over u squared. Okay, so before we had one fraction on the top, two fractions on the bottom. For this example, they're kind of switching it up. Two fractions on the top, one fraction on the bottom. The idea is the same though. So for the two fractions on the top, that's where we need the common denominator. So this time I get to kind of ignore that fraction on the bottom. I'm going to look at the top and I'm going to find a common denominator between the two. So since I'm subtracting fractions, that's where I need a common denominator. Okay. Now, I can write out a list of steps. If that's something that you want to do after the video, if you say, Ms. Rice, tomorrow in class, can we sit down and write down a list of steps? What do you do first? What do you do second? What do you do third? We can do that. It's easier to do this problem if you don't memorize a list of steps. If you've paid attention in class and listened to the problems and kind of understand what do we do when we see certain things. So when I see two fractions and I need to add or subtract them, I have to find a common denominator. So since I've seen that in this problem, I should recognize that's what I need to do. Over here, when I'm dividing two fractions, I got to keep change flip. So it's not a step I need to memorize. I just know whenever I see two fractions divided, that's what I've got to do. Here, simplify something like this. I need to factor before I cancel. I don't need to memorize that's a step, that's just something I know I have to do. So it's a little bit easier if you just recognize that some of these things are things that we just have to do. But if you guys need me to sit down and write down the steps, we can do that in class. All right, so common denominator, we've got a u, we've got a 9, so our common denominator is 9u. Okay, so first fraction we multiply by 9, second fraction we multiply by u. I'm going to go ahead and rewrite what I have. I've got 9 over 9u minus 5u over 9u. And I'll go ahead and write the top as just one fraction. Sorry, kind of slanted. Okay, so at this point, I have a fraction divided by a fraction. So this is when I keep it, change it, flip it. So keep the top same. Change it to a multiplication problem, flip the and then from here, this is when I start to factor things. Now, I've noticed that right here, this stuff looks like, I mean, there's nothing I can really do with it. But this part right here is written incorrectly. It's in the wrong order. So what I'm going to do is I'm going to go ahead and fix that order. It should be negative 5u and a positive 9. That is in the incorrect order. Now, whenever I have something that has a negative first, that negative should be factored out. So it's written as a binomial, which means that when I factor it, I would try to take out a GCF as if I could. There's no GCF between 5 and 9, so it looks like if I'm going to factor it, the negative is the only thing I can take out. So negative 5u, negative is a positive 5u. Positive 9 divided by a negative is a negative. And then 9u, u squared. So now the interesting thing that happened is that when I took out that negative, these can cancel all of a sudden. All right? And this is a u squared, so if I were to write that kind of expanded, that would mean that I have u times u, which means that I can cancel out one of those with the u down here. So what I end up with on this problem is negative u over 9. That's my final answer. All right, I'm going to end the video there. I say more for tomorrow, and then write a note to yourself. If you want me to write out the steps tomorrow in class, I can do that for you. So you just have to tell me that that's what you want.